Okay, guys, before we get started into the next lesson, I know I didn't post the video for the rotation and translation, so I thought I'd put them up at the beginning of this video. So if you just wanna, I'm gonna go through this really quick. You can pause it. There are the definitions. Okay, and that's the grid of the original slide. If you guys wanna, you can do those translations on your own. And here is the rotation. I'll try and click through all those coordinates really quick. But they are there. You guys can pause it and come on. There we go. Oh. There it is. There it is. And there they are. And finally, there you go. There's that chart if you want to fill it out, if you didn't get in class or just want more time. So with that, let's move on to the next chapter. But before we do that, Caleb had requested that I have a joke in each video, so I decided to do that. So for this video, the joke is, what do you call friends who love math? What do you call friends who love math? And I will either answer that at the end of the video or maybe in class tomorrow. We'll see. So, moving on. Okay. Our subject of this video is going to be the next form of transformations. So we have similarity and dilations. Move on, start with a few vocabulary terms. So similar polygons are polygons that have the same shape but can be different in size. So they're more like shrunken down or stretched out versions of an original image or original object or figure. And for the transformation is actually going to be the dilation, which is either stretches or shrinks the figure. So you're either going to take it and, make it larger, or you're going to make it smaller. And then you have the scale factor, which goes along with that dilation. So that is the ratio of a side length after a dilation to its length before the dilation. So you'll have your ratio of how big it was before, how big it was after. So that's, in other words, that's all it's saying is the amount the side length is multiplied by to find the side length of the image. So how much did we multiply that first to get the second? Okay? So let's jump right into it with the example. So first off, go ahead, pause the video, find out what those coordinates are for the original polygon. All right, so there they are, appearing out of nowhere, my magic. There they are. So there's your original coordinates for that. So now we're going to dilate this polygon with a scale factor of 3. So we're going to multiply each coordinate by 3 to stretch it out bigger. So now if you would pause the video and multiply all of your XY coordinates by 3 to create the new polygon. Go ahead and do that now. So hopefully you have gotten the same new coordinates as I have. I multiplied each number. So for A, we got -3, -3. For the new B, we have 0, 3. For C, we have 6, 6. And then for D, we have 9, 0. So now, once again, when you pause the video and go ahead and go to step 3 and use those points from step 2 to plot the new image. And then we'll come back and see if yours matches mine. So hopefully, now that you have plotted those points, yours looks just like mine. So there you go. That would be a dilation where we stretched it out. We multiplied it by 3. Now we'll do this one. So we're going to start with the same points, do the coordinates, and then move on to step 2, where we're going to multiply the coordinates by the scaling factor, which for this one is k equals 1/2. So now go ahead and pause the video and figure out those original coordinates, and then we'll be back. So now that we have those, go ahead and pause the video and multiply each of the coordinates by the scaling factor and figure out what you get for the new points for that triangle. All right, so now that we have multiplied each of the 3 coordinates by 1/2, hopefully yours matches up with mine. And now all we're going to have to do is plot that image and create our new triangle, our smaller triangle, because this one's going to shrink down. So go ahead, pause the video, do that now, and then when we come back, hopefully yours matches mine. And there we go. So there we have our shrunken down triangle from the original. Those coordinates from what we got from multiplying it by 1/2. So here we have our dilations for this one and this polygon here. Even though they are different in size, they're going to be similar because everything is, it's a ratio. So all its side lengths are proportional. So they are similar. They're not congruent, but similar polygons means they have the same, this triangle, all its interior, both, those interior angles are going to be equal to that interior angle. It's just shrunken down, so they're similar. So that concludes our video for similarity and dilations. The joke. Let's see. What do you call friends who love math? You call them algebros. That was really bad. Oh well, there you go. There's your joke. And I will see you in class tomorrow.